Here is a compressed map of the AI stack in late July 2026. NVIDIA reportedly pairs a major equity investment with privileged access to next-generation compute for Safe Superintelligence. TSMC evacuates its Kumamoto facility after a powerful earthquake, then reports no structural damage. Moonshot AI releases Kimi K3, a massive open-weight model, alongside same-day hosting support and a commercial license that is open only up to a point. And China launches Waco, a new intergovernmental AI governance body headquartered in Shanghai. These are not isolated headlines about one partnership, one fab, one model, and one institution. They point to the same underlying shift. The real contest in AI is no longer only about model quality. It is increasingly about who controls access, on what terms, and at which layer of the stack. Start with compute allocation, because that sets the frame for everything else. On July 27, 2026, NVIDIA and Safe Superintelligence entered a long-term strategic partnership. NVIDIA is reported to have made a substantial equity investment in SSI, valued at $5 billion, while also granting SSI access to NVIDIA's next-generation Vera Rubin platform. SSI's research compute capacity is expected to rise roughly tenfold over the coming year. The strategic significance is not just scale, it is the form of access. Compute is no longer simply hardware to be bought or rented in a neutral market. At the frontier, it is increasingly bundled with capital, strategic alignment, and preferential platform access. That changes who can move quickly, who can scale, and who may be forced to wait. For Asia, the relevance is indirect but material. Delivering compute at this level depends on semiconductor fabrication, advanced packaging, and system-level supply chains that run heavily through Asian manufacturing. So even when the headline sits in Silicon Valley, the operational foundation still runs through Asia. The promise of privileged compute access matters only if the chips behind that promise can be produced, assembled, and delivered at the required pace. That leads directly to the physical layer beneath the AI boom: fab resilience. TSMC's Kumamoto facility became the focus after a 7.1 magnitude earthquake struck southern Kyushu and triggered emergency evacuation procedures. TSMC later confirmed that all personnel were safe, inspections found no structural damage, and operations were gradually resuming. Based on the reporting, this should be understood as a contained event, not a confirmed supply shock. There's no confirmed disruption to output or shipments. Still, the broader lesson is important. Geographic diversification away from Taiwan does not remove risk. It changes the risk profile. Japan may ease some of the concentration concerns associated with cross-strait tensions, but Kyushu remains an earthquake-prone region. That matters because compute commitments at the frontier ultimately rest on factories that must keep operating under real physical stress. Strategic partnerships and capacity pledges can shape market access, but those promises depend on fabs that are resilient enough to absorb shocks, inspect quickly, and restart safely. In that sense, compute allocation and manufacturing resilience are not separate stories. One only works if the other holds. With compute and manufacturing in place, the next control point is the model layer itself. Moonshot AI's Kimi K3 release is the clearest signal here. According to the reporting, Moonshot released open weights for a 2.8 trillion parameter mixture of experts model with a 1 million token context window and native multimodal capabilities. The size is notable, but the more important point is how the model became usable immediately. Together, AI and modal reportedly provided day zero hosting access, so developers did not have to wait for infrastructure support after the release. That matters because open weights alone do not guarantee practical access. A model can be publicly released and still remain out of reach if few organizations can host it efficiently. For most developers and businesses, availability without infrastructure is only partial availability. Kimi K3 suggests that open weight strategy is increasingly a joint exercise between the lab, releasing the model, and the infrastructure providers that can operationalize it from day one. At the same time, caution is warranted. The reporting does not provide pricing, benchmark comparisons, hardware requirements, or throughput data. So broader claims about cost efficiency or competitive advantage should not be assumed beyond what is actually stated. The licensing structure adds a sharper layer to the story. Moonshot AI released Kimi K3 on July 27, 2026, describing it as a 2.8 trillion parameter model with a 1.56 terabyte footprint hosted on Hugging Face. But the attached license is not fully permissive. It restricts large model-as-a-service businesses earning more than $20 million annually, requiring those companies to negotiate separate commercial agreements before deploying the model at that scale. This is a meaningful distinction. Open weights do not necessarily mean open source in the traditional sense, and they do not automatically eliminate monetization control. Moonshot's structure appears designed to widen access for developers, researchers, and smaller-scale deployment, while preserving bargaining power over the largest commercial service providers. In other words, open distribution and revenue capture are not being treated as opposites. They're being combined. That may prove important if more model developers adopt the same approach. Use openness to drive reach and ecosystem adoption, but reserve economic leverage where the largest hosting businesses stand to benefit most. For model licensing, the story shifts to a different type of control altogether: institutional governance. China formally launched the World Artificial Intelligence Cooperation Organization, or WICO, at the World AI Conference in Shanghai. 29 founding nations joined, including Pakistan, Indonesia, Kazakhstan, and Russia. And the organization will be headquartered in Shanghai. The stated framing emphasizes a global South orientation, digital sovereignty, and technology sharing among member states. This is a different layer of the stack, but it is still about access. Chips determine who can compute. Hosting determines who can deploy. Licensing determines who can monetize. Governance institutions can shape who gets influence over the rules, language, and channels through which AI policy is coordinated. WICO, at least in its stated form, looks like an effort to build an alternative forum for that coordination beyond the traditional Western-centered policy conversation. The open question is whether WICO becomes operationally meaningful or remains primarily a launch signal. The reporting describes it as a China-led intergovernmental initiative, framed as an alternative global AI governance platform. But it does not establish binding standards, confirmed funding structures, or immediate commercial effects. So the key issue now is follow-through. Membership details, institutional structure, technical mandates, and any future working mechanisms will matter more than the launch itself. For now, WICO represents institutional ambition. Whether it develops into a real governance choke point is still unresolved. Taken together, these 6 developments describe one coherent shift across the AI stack. NVIDIA and SSI show that frontier compute can be allocated through strategic partnerships bundled with capital, not simply purchased in an open market. TSMC's Kumamoto response shows that this layer still depends on physical manufacturing resilience under real-world stress. Kimi K3 shows that model access can be widened through open weights, but only becomes operationally meaningful when hosting arrives immediately with it. Its license then shows that broad distribution can still coexist with tight commercial control. And WICO shows that influence over AI governance is also becoming organized through new institutions, particularly those aimed at the global South. The common thread is not a ranking of which model is best this quarter. It is a contest over choke points in the terms of participation. For investors, that means tracking 4 layers at once. Watch compute allocation to see whether more leading labs secure equity-linked capacity deals from major infrastructure providers. Watch semiconductor resilience, especially fab hardening, restart discipline, and site-level continuity across Asia. Watch model commercialization to see whether open weight releases gain real traction only when paired with hosting, and whether revenue-based licensing restrictions spread more widely. And watch governance to see whether WICO develops concrete mechanisms, expands its membership, or starts shaping procurement and policy alignment among member states. The practical takeaway is straightforward. AI exposure should be evaluated across the full stack, not only at the level of model capability. In this phase of the market, access itself is becoming the scarce asset.